Exponential equations. We're going to start at the point 0, 1 because anything to the 0 power is 1. Okay? Remember that exponential functions and log functions are inverses of each other. So since they're inverses, if exponential functions start at 0, 1, log functions should start at 1, 0 because, again, they are inverses. So you're switching x and y. If you switch x and y, that means the domain and range also switch. Okay? Now, star these because these, every time you know it's an exponential equation, we're going to start at 0, 1. Every time it's a log equation, we're going to start at 1, 0. And here's something cool too. LOG, LO looks like 1, 0. Exponential functions, exponential growth functions will look like this. Log functions will be flipped over that y equals x line and look like this. So exponential shape, log shape. Exponential functions have horizontal asymptotes, and if it's horizontal, it has to be y equals. Okay, so horizontal asymptote. What's the opposite of horizontal? Vertical. So that means that log functions are going to have a vertical asymptote, and instead of it being y equals, it is x equals. Exponential functions have a domain that stretches from negative infinity to positive infinity, which means if the domain is all reals for exponential functions, if I switch it again, the range should be from negative infinity to positive infinity. Okay, number 1, here we go. Exponential function. I'll start at the point 0, 1. So I'm not in pen, in pencil, I'm going to go over here and I'm going to plot the point 0, 1. 0, 1, which is on the y-axis, okay? One of the most important parts of this is to figure out what is my base. My base of the exponential function is 2. So the base tells you exactly what you're multiplying each time. So if my base is 2, then I am doubling. If it's 3, I'm tripling. If it's 4, I'm quadrupling. So as the base increases, the values from the asymptote also increase. So the base is 2. Okay, transformations, left, right, up, and down. So up here, I have x plus 2, which goes left 2. And remember, the left and right, you always do opposite of what you see. So x plus 2 is left 2. And then plus 2 outside is up 2. Left 2, up 2. I'm going to put a D for domain and R for range. My domain we already know because it's an exponential function and the domain is all reals, which means that every single x value I can put any number in and I'll get a y value back out. But this range will be restricted. Put HA, which stands for horizontal asymptote, and go ahead right now and put y equals. Hey, HAY, hey. Anybody? No? All right. This is the stuff that we're going to need each time. So let's kind of go ahead and move the point that we started with. So I'm going to start again with the point 0, 1. So here's 0, 1. Boom. Okay. From 0, 1, I need to move it left 2, up 2. Left 2, and up 2. And when you're graphing, you can graph the asymptote first, or you can graph that point. But the cool thing about graphing the point first is that now the asymptote will be always 1 away from it. So if it's horizontal, and you can kind of see my pencil now, right? If I move it left and right, I can move this. Let me get it to where you can see something. I can move this left and right, but it will not move the asymptote. It'll stay here. But if I go up and down, it's going to actually move it. So exponential functions, if I go up and down, it's going to move it. So since I went up 2, my horizontal asymptote is at y equals 2. And that makes perfect sense because my point is 1 away from what I just highlighted in yellow. 1 away is good. I cannot touch the asymptote. It will never touch it. Actually, this left-hand side will get really, really close. I call it tailing it off. So if you tail it off all the way down, that's what that end will be, and it will never touch the asymptote, which again is at 2 because I went up 2. Okay. Now I would be able to know my range because the asymptote, you're actually going to restrict it at that number 2, and then I'm staying above the line, which means that it goes to positive infinity. So your asymptote number will also be in your range for exponentials, and so you'll always duplicate that number either in the domain or range. Kind of it depends on if you're graphing exponential functions or log functions. This part that I'm about to do next is the most crucial part, and it is all based off the base. Now, if I'm right here, notice again, I am 1 away. So I highlighted it at a horizontal line at 2, so y equals 2. Okay, and I'm going to put this here too, y equals 2. And I'm going to double it now. So you will always start 1 away. So I'm going to double that height from the asymptote. So 1 times 2 is 2, and listen to this, 2 away from the asymptote. 2 away from the asymptote. 2 times 2 is 4. Away from the asymptote. Away from the asymptote. 4 times 2 is 8. Why am I multiplying by 2 each time? Because the base is 2. Since my base is 2, I have to keep multiplying by 2 the whole entire time until I get what I need. And I'll move my paper like this. The next one would be 8 times 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I did that completely wrong, but it should be 16 to 18. Perfect. And I'm going to take and I'm going to graph through these points. Let me graph these points obnoxiously so you should be able to see each point. Here we go. Number 3. First step. I'm going to start at 1, 0. Second step. I'm going to do base of 4. Base of 4 means I'm going to quadruple. Okay. I'm going to put my transformation. So this right here is right 1. This is down 1, right 1, down 1. I want my domain, I want my range, and the asymptote. The asymptote will be VA because it is a vertical asymptote, which is x equals. The range will be all real numbers. I'm going to go ahead and plot my point 1, 0 now. Okay, from 1, 0, I do the transformations. I need to take it right 1, down 1. So right 1, down 1. Right 1, down 1. I'm going to erase the original point. If I go up and down, it will not affect the vertical asymptote. So if I go up and down, it doesn't affect it because it's vertical. But if I go left and right, it will affect it. And again, you want to make sure that you are 1 away. 1 away from that original starting point. So since I went right 1, the asymptote number is 1, and my domain is 1, positive infinity. Okay, and again, right 1 asymptote number here, which now would be on the inside and not the outside like exponential functions were. Okay, tail down, base of 4, 1 away from the asymptote, 1 times 4 is 4. 1, 2, 3, 4, there we go. 4 times 4 is 16, it goes off the graph, so those are the 2 points that you need. So this is the point 2 comma negative 1, and this is the point 5 comma 0. 2 negative 1 you need, 5 comma 0 you need, and this is done.